The proposed mechanism for a reaction is A plus B yields to X. That is reversible reaction. Then the second step is X plus C, which yields to Y. And then the third step is Y yields to D. Okay, so what is the overall equation? Now let's write the reaction here. A plus B. So this is a fast reaction. Okay, fast. And then for the second step, okay, so X appears as a product in the first step, and X is used as our reactant for the second step. This yields to Y. Okay? And then the Y, we use Y in our reactant, which proceeds or yields to D. What is the overall equation? So the second step is slow, and the third step is fast. Sorry, it's raining here. Okay. Now, okay, so let's look for intermediate reactions. Okay, can we find intermediate reactions here? Yes, we have the X, and also the Y. You see, X appears as a product and consumed and was consumed. And also, Y also appears as a product and was consumed. Okay, no more. So, for an overall reaction, we have A plus B, then plus C, yields to D. Okay, so this is our overall reaction equation. Now, what is letter B? Identify the intermediates, if any. Okay, so we have identified them already. I'll just box this one. Okay, this is letter A. Now, for letter B, the intermediates are X and Y. Okay, letter C. What are the molecularity and the rate law for each step? Okay, molecularity. In the first step, okay, we have first, second, third. So first step is how many reactants? We have two. So we can say that it is by molecular. Okay. And for the second step, this is for first. Okay, for the second step, we have two again, the X and C. So we have bimolecular. And for the third step, we have only, okay, we have one. So that is unimolecular. Okay, so we are going to write the rate law. Okay, the rate law for each step. So we have step 1, the rate law is rate is equal to K times A and B. For the second step, we have rate is constant times X times C. And the rate here is K times Y. Okay, so that is letter C. Now, what is letter D? So, letter D, we are asked of Letter D. Is the mechanism consistent with the actual rate law? K, okay, times A times B times C. Okay, is it consistent? All right, now let's look at the overall rate law. The overall rate law is rate is equal to K times here A times B times C. Now, is it consistent with what is asked? Yes, it is. So our answer is yes. Now, letter E. Letter E. Is the following one-step mechanism equally valid? We have A plus B plus C, which yields to D. Okay, so we are asked here that if we don't show the mechanism, the first, the second, and the third step mechanism, if instead of just one step or the final step, is it equally valid? Is it equal to this? Okay, by answering that, we will look at the overall rate equation. Okay, now as we can see that the overall rate here is K times A times B times C. Okay, and this is equal to the proposed. Okay, this is equal to the proposed mechanism, which is A plus B plus C, which yields to D. Okay, so our answer is yes, the proposed mechanism is valid because the overall equation in the rate law for the mechanism matches the observed rate law. Okay, so that's it. They are equal and it is valid.